Good morning to one and all. Today we discuss about the vector data model. In last class we have studied raster data model that is represent the cell. So here vector data model, it contains the line, point, polygon. So now we go brief. Three fundamental factors, three vector types exist in geographic information system: points, lines, and polygons. Points are zero-dimensional objects that contain only single coordinate pair, are typically used model singular discrete features such as buildings, wells, power poles, sample locations, and so forth. Points have only the property of location. Other types of point features include the node and the vertex. Specifically, a point is a standalone feature, while a node is a topological junction representing a common xy coordinate pair between intersecting lines and polygons. Vertices are defined as each bend along a line or polygon features that is not the intersection of the lines or polygons. See here, this is a feature vector diagram. So these two dots represent the points. Okay, this is the point. And polygon, polygon. See, enter this session. So enter this session. Okay, this is polygon and line. So each line. Okay, these are the lines. This line. So points, and lines and polygons. uh, Polygons. These are represent the vector data model. Points can be spatially linked to form more complex features. Lines are one-dimensional feature composed of multiple explicitly connected points. Lines are used to represent linear features such as roads, streams, faults, boundaries, and so forth. Lines have the property of length. Lines that directly connect two nodes are sometimes referred to as a chains, edges, segments, or arcs. Next and last one is the polygons. Polygons are two-dimensional features created by multiple lines that loop back to create a closed feature. In the case of polygons, the first coordinate pair on the first line segment is the same as the last coordinate pair on the last line segment. Polygons are used to represent features such as city boundaries, geological formations, lakes, soil associations, vegetation, communities, and so forth. Polygons have the properties of area and perimeter. Polygons are also called areas. Next, vector data models structures. So here, the simplest vector data structure is called spaghetti data model. In the spaghetti data model, each point, line, or polygon feature is represented as a string of xy coordinate pairs, or as a xy coordinate pair in the case of vector image with a single point. With no inherent structure, one could envision each line in this model to be a single strand of spaghetti that is formed into complex shapes by the addition of more and more strands of spaghetti. It is notable that in this model, any polygons that lie adjacent to each other must be made up of their own lines or strands of spaghetti. In other words, each polygon must be uniquely defined by its own set of xy coordinate pairs, even if the adjacent polygons share the exact same boundary information. This creates some redundancies within the data model and therefore reduce efficiency. This is a spaghetti data model. So, each line and point and polygons, so they are represented the different vertices. So so what are the vertices they are represented, they are given here. So xy coordinate system spaghettis. Next, topological data model. It is a very important. The topological data model is characterized by the inclusion of topological features within the dataset. As the name implies, topology is a set of rules that model the relationships between neighboring points, lines, and polygons, and determines now how, how they share geometry. For example, consider two adjacent polygons. In the spaghetti model, the shared boundary in two neighboring polygons is defined as two separate, identical lines. The inclusion of topology into the data model allows for single line to represent these shared boundaries with an explicit reference to denote which side of the lines belong with which polygon. Topology is also concerned with preserving spatial properties when the forms are bent, stretched, or placed under similar geometric transformations, which allow for more efficient projections, reprojections of maps files. Three basic topological aspects that are necessary to understand the topological data model are outlined here. First, connectivity. Connectivity describes the arc node topology for feature datasets. As discussed previously, arc node topology for the feature datasets. As discussed previously, nodes are more than simple points. In the topological data model, nodes are the intersection points where two or more arcs meet. In the case of arc node topology, arcs have both a form and node, indicating where the arc begins, and a two node, indicating where the arc ends. In addition, between each node pair is a line segment, sometimes called link, which has its own identification number reference both its from node to node. See here different arc node topology, different arcs is there. So A arc, it consists of 16 and 17. B arc 14, 17. For example, F 17, 21. So E 18, 19. So this is a attribute table. This is the arc node connections. The second basic topological perspective is area definition. Area definition states that an arc that connects to surround an area defines a polygon is called polygon arc topology. In the case of polygon arc topology, arcs are used to construct polygons. Each arc stored only in the once this result reductions the amount of data stored ensure that adjacent polygon boundaries do not overlap. That's important. So adjacent boundaries, for example, this is a polygon. Okay, this is another bound. So these two are not overlap. Okay, exactly we have to attach these two polygons. Okay, like this. So see here, C 2, 3, 4, 6. For example, D. So how many has there? 4, 5, 7, 8, 12, 5. 5 nodes and connection of the polygons. Last one is the contiguity. The third topological perspective is based on the concept that polygons that share a boundary are deemed adjacent. Specifically, polygon topology requires that all arcs in a polygon have a direction, which allows the adjacency information to be determined. Polygons that share an arc are deemed adjacent or continuous, and therefore left and right side each arc can be defined. This left and right polygon information is stored explicitly within the attribute information of the topological data model. The universe polygon is an essential component of polygon topology that represents the external area located outside of the study area. So yeah, for example, the polygon starts from here and just travel in this direction, okay, and end its. So like that, single arc it connects the A B, and second arc it connects the C and A, top of A, and 5 is connect the B D, and 7 E D, 8 F D, like that. Once it's started, for example, here it started the polygon, and again B is connected the D, so like this. Okay, again, so once it's connected AB, so BD. So this is the continuity. Next one is the shape file. It is very important. Before start drawing, we have to create a shape files. So depends on the land features. The shapefile is a non-topological data structure that does not explicitly store topological relationship. However, unlike other simple graphic data structure, shapefile polygons are represented by one or more rings. A ring is a closed, non-self-intersecting loop. This structure can represent complex structures such as polygons that contain islands. The vertices of a ring maintain a consistent clockwise order so that the area to the right as one walks along the ring boundaries is inside the polygon, and the area to the left is outside the polygon. Moreover, polygon features in shapefile format can contain one or more parts so that disjunct and overlapping features can be represented. For example, an individual parcel that is split by road can be represented alternatively as two separate polygons with two rings and two records in the attribute table, or one polygon with two parts and one record in the attribute table. A source of confusion for some users is that some ArcView.js commands can result spatially disjunct multi-part features. The primary advantage of shapefile is that the simple file structure grows faster than a coverage does. This may be why the shapefile data structure was developed for ArcView.js, a software program that was originally designed for data viewing rather than analysis. In addition, shapefile can easily be copied and do not require importing and exporting as do .e00 format files. The shapefile specification is readily available and a number of other software packages supported. These reasons have contributed to the emergence of the shapefile as a leading JS data transfer standard. However, these advantages do not fully explain the resurgence and non-topological data structure. Next topic is a object-based vector data model. In exam point of view, it is very important. It is a georelational data model. It is a split system. Object-based models store spatial and attribute data together rather than in split system. Geometry, nothing spatial data stored as an attribute along with other attributes, eliminates use of split system and need for data synchronization. Object-based data model contains Windows environment minus icons instead of command lines. Model treats spatial data as objects. Object can represent a spatial features. Object can also represent a layer or the coordinate system on which the layer is based. Two difference between georelational and object-based data model. It stored a single system rather than split. For example, a land use data set, object ID 123 and shape files are polygon. So here shape length and area. This figure, the object-based data model stored each land use polygon, a record, a shape file stored in spatial data of land use polygons. Other fields are stored attribute data such as land use ID and category. So this is attribute data. Enter. A major breakthrough. Using a single system is a major breakthrough because software developers must regularly deal with issue of data storage and data structure. Second difference between the georelational and object-based data models, it allows the spatial features to be associated with the properties and methods. Property and method. Property, an attribute or characteristic of an object. Method, a specific action that can be performed on an object. Classes, set of objects with similar characteristics, hierarchical structure, feature class, dataset, the store feature of the same geometry type in the database. Geometry. Geometry, it contains point, line, polygon. So this figure, geometry properties feature class can difference object of point, line and polygon. Relationship between classes. Following grouping objects into classes, we must then sort out the relationship between classes. Association, aggregation, composition, type inherent, and Insta instantiation. Association. First one. How one class may be associated with another. Streets and single lights. Street can be associated with one or more street lights, but with only one coordinate system. Street, single signal light, street, and coordinate system. Aggregation. Whole part of relationship between classes. One class is part of another class. State is an aggregate of counties. Composition. Similar to aggregation, the composite owns the parts. Highway may have may have from 0 to any number of rest areas, and the lifetime of the rest areas are controlled by existence of the highway. Type of inheritance. Difference defines relationship between superclass and a subclass. Subclass is a member of the superclass and inherits the properties and methods of the superclass. Subclass can be additional properties not common to the rest of the superclass. Build-up area. Build-up area covers residential area, commercial, industrial areas. The example of type of inheritance. Instantaneous object. One class may be created from objective of another class. Residential area. High density residential area. Is connectivity. Okay. So summary of object-based vector data model. It relationship between classes following grouping of object into classes. So we must then sort of the relationship between classes. All these association, aggregation, composition, type of inheritance, and instantaneous. Thank you for watching.